Welcome to our demonstration of DSA 2.9. We're going to do a very simple calibration today. A single accelerometer is mounted on a handheld shaker that puts out a known amplitude of 1G at approximately 160 Hertz. So we're going to take this reference signal and we're going to measure it with one of the modules in our 9178 8-slot chassis, and the module that we're going to be measuring with is a 9234 that's plugged into the chassis. Okay, so to begin, we'll go to our Configure tab, and here we will enable the channel we want to measure on. So we refresh the hardware, it detects automatically everything plugged in on the USB port. The first module is our 9234 in the first slot. We turn on the first channel by flipping the red X to a nice green check. We turn on IEP because the accelerometer requires that. To operate correctly, we'll leave it on AC coupling. We're going to leave sensitivity alone at 1000 millivolts per engineering unit, and we're going to set the engineering unit to G's right there. And that pretty much is all we have to do to get ready to make a measurement. We do have to make sure our sample rate is a proper value. 2000 Hertz or 2000 samples per second is just fine. And then we save the configuration. So now we should be ready to acquire the signal in the form of a voltage. So go to the Acquire tab, and we can see all the parameters that we need to make a proper measurement. So the next thing we're going to do is set up our processing parameters to measure this voltage and convert it into a spectrum. So we'll start out with RMS averaging. We'll do an exponential weighting with 3 averages here. We'll do a block size of 4096. That should work nicely. 75% overlap, and a flat top window. You always use a flat top window when you're performing a calibration because it will give you the most accurate estimate of a tonal amplitude. The units we're going to select will be engineering units RMS or EURMS. So the pull down here lets you pick whatever unit you want the measurement to be represented in. And all we have to do now is we'll put this processing back up here and come down here and hit the arm button. We should see a wiggly line come across, and as soon as I turn on the calibrator, we should see a nice tone. So the tone's coming across and the peak is down below. If we would like to, we can zoom in. We'll just turn off the x-axis auto scaling and grab our zoom tool here and zoom in on it so we can see what we're doing. Up on top we have this sine wave coming in. We could also unlock x-axis scaling there and grab our zoom tool and zoom in on a little section of that if you want to see what the sinusoid looks like. Right now, we're looking at a unit of G, but it's not been calibrated yet. I'm just going to switch it over to volts. So now we're actually seeing the true voltage value coming in from the accelerometer. In the bottom graph, I have y-axis auto scaling turned on. The peak is right at the top of the graph. So the value over here represents the volts RMS that is being produced by the sensor, measured by the front end, and turned into a value here. So we're seeing 0.0106 volts corresponding to 1G RMS coming from the calibrator. So our sensitivity is simply it's going to be 10.6 millivolts per G. So let's go ahead and stop this, come over to the Configure tab, and type in 10.64, I think it was, millivolts per G as a sensitivity. And we'll actually name this channel. We'll call this accelerometer. So now we save that configuration, come back over to the Acquire tab, hit the arm button, and we should see our peak again. Turn the calibrator back on and switch over to engineering units, and if all goes well, once the average settles, we should see it come in right on 1G RMS. And there you have it. We're all done. That's how you calibrate a channel in DSA 2.9.